Welcome, friends. This is the answers explaining session. Okay, first of all, I will explain the answers for today's question, then I will explain the answers for task 5 questions. Okay, let's start now. Okay, this is the first question, which is from heat exchangers topic. Okay, first of all, I will read the question. In a counterflow heat exchanger, water is heated at a rate of 1.5 kg per second from 40 degrees Celsius to 80 degrees Celsius by an oil entering at 120 degrees Celsius and leaving at 60 degrees Celsius. The specific heat of water and oil are 4.2 kilojoule per kg Kelvin and 2 kilojoule per kg Kelvin respectively. The overall heat transfer coefficient is 400 watt per meter square Kelvin. The required heat transfer surface area in meter square we have to find, that is we have to find the surface area in meter square. Okay, I have derived and solved the answer for this question. I will show you the answers now. Okay, first of all, before going into the solution, what are the given data? Let me see. First of all, m dot, that is mass flow rate for cold fluid, is 1.5 kg per second. Okay, and temperature for hot fluid and cold fluid is written in the screen. Okay, specific heat also given and overall heat transfer coefficient is also given. Okay, we have to find the surface area. This is the general plot for counterflow heat exchanger. Now we are going to find the surface area using LMTD method, that is logarithmic mean temperature difference method. Okay, for that formula is heat transfer rate Q is equal to U overall heat transfer coefficient into surface area A into del Tm, that is the logarithmic mean temperature difference. Okay, what is the logarithmic mean temperature difference formula? That is theta 1 minus theta 2 by ln of theta 1 by theta 2. Theta 1 means, look at the graph at the left side, that is theta 1, that is temperature difference is theta 1. Okay, in the left side Thi minus Tc naught and right side Th naught by minus Tci. Okay, this is the main in heat exchangers. You have somebody always made a mistake in this part only, that is taking theta is the main part while solving the heat exchanger. We have to read carefully. The question is whether counter flow or parallel flow, then we have to select the theta 1 theta 2 correctly. Okay, hence it's a better way to choose in correct manner is by plotting a graph. You can choose the theta 1 theta 2 correctly. Okay, therefore whenever you solve the heat exchanger problems, either parallel flow or counter flow, you put a plot first of all, then there will be no confusions. Okay, okay, theta 1 and theta 2 find out. We are getting 40 and 20 degrees Celsius. Now substitute in this formula, you can get the theta del Tm as 28.86 degrees Celsius. Okay, then from this formula, area is equal to Q by U into delta Tm. Okay, before that we didn't know what is Q, therefore we have to find the Q. For that formula is general formula mCp delta T, using for cold fluid IM, either you can use cold fluid or hot fluid, answers will be both or same. Okay, here I used for cold fluid. I have found the Q value and substituting in the area formula, and finally I am attaining the answer as 21.875 meter square. This is the exact answer for that question. Okay, 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 now I will explain the answers for yesterday's question. Okay, first this is the first question of yesterday, which is the question from general aptitude section. Okay, here the question is, 7 machines take 7 minutes to make a 7 identical toys at the same rate. How many minutes would it take for 100 machines to make a 100 toys? Here we have to read carefully. Okay, while we are reading the question, we will directly select here the option as C 100, because we will think as logically, okay, 7 machines, 7 minutes, 7 identical, therefore 100 machines, 100 toys and 100 minutes. But it is wrong way. Okay, it is a wrong way. We have to choose the answer correctly. Okay, for that I will show and explain the answers. Okay, this is the solution for that question. If you don't want to remember this type of formula at all, okay, they are given the first statement. From this first statement we can find this type of formulas. Okay, they have given that 7 machines take 7 minutes to produce 7 toys. Okay, here we have to find the relation. Okay, they itself given the answer in the first statement. For 7 machines, 7 toys, the time is 7 minutes. Okay, mm, by this you think a logic what it is means. Okay, what it means, missions into time. Okay, divided by number of times toys. That is, missions and number of toys will be inversely proportional. No, it's wrong. Missions and number of toys will be directly proportional. If there is more missions, we can produce more toys. Therefore these two are directly proportional and time will be inversely proportional. By relating this way we can find the formula for this type of questions. Okay, I have founded the formula. Now substitute. Okay, where you have to substitute, we have to substitute the statement 1 with statement 2. So we have to equate the both statements and find the time. By finding that way we are getting the answer as 7 minutes. Okay, this type of questions we have to think carefully. Whenever you solve a questions in a GATE exam, there will be a some logic or some trick we have to, or some trick, that is some twist will be there. We have to find that and answers for that. Okay, 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 this is the second question, which is from our topic, heat and mass transfer. First of all, I will read the question. Okay, a plain slab of thickness L and thermal conductivity K is heated with a fluid on one side P and the other side Q is maintained at the constant temperature of TQ of 25 degrees Celsius as shown in the figure. Okay, this is the figure. The fluid is 45 degrees Celsius and the surface heat transfer coefficient H is also given as 10 watt per meter square Kelvin. The steady state temperature at P, okay, in degrees Celsius we have to find the answer. Okay, we have to find the TP. Here look at the figure. This is a plain slab, that is the through a fluid the heat is passed through the slab and through the slab of one end to other end is heat is transferring. First the fluid to the one end of the slab is through convection it will be transferred, and from one end to another end of the slab the heat is transferred through conduction. So therefore here there are two heat transfer mode, one is convection and one is conduction. Now I will show the answer which I had solved. Okay, this is the sheet where I solved this question. Okay, given data is we can find from the figure itself. Okay, they are given the steady state. This is the main keyword. Okay, steady state means at all points the heat transfer rate will be constant. Okay, so therefore Q1, that is through convection, and Q2, which is the through conduction, and Q overall, all the heat transfer will be equal. So by relating this we have to find the TP, which is the first end of the conductor, first end of the slab, that is we have to find the temperature at this end. Okay, at this end or at this surface. So Q1 means through convection, hence convection heat transfer formula is heat transfer coefficient into surface area into temperature difference. This is conduction, you already know that. Overall means the temperature difference will be from TF and TQ, that is first end and final end. Okay, by using this equating any two. Okay, it is your wish. If you equate the q1 and q2, it will be simple to find the answer. Okay. I have taken here as q overall is and q conduction. So this is I have solved. This is simple calculation only. If you watch it, you will understand clearly. If you have any doubts, please post it in comment. Okay, we are getting TPS 33.88 degrees Celsius. Okay, and subscribe my channel and click the bell icon to receive daily questions daily. Okay, thank you.